Students, this is the help video for Unit 6 Study Guide, problems H, I, and J. In a proof, we have here a quadrilateral with our given coordinates. We want to prove that this quadrilateral is a parallelogram, but not a rectangle. So this is called a double proof. You have to positively prove something, but negatively disprove something else. The language we're using here is midpoint, slope, and distance. It's important to ask yourself, what do you know about the shapes? So to prove something that is a parallelogram, you need one of the OCD qualities. So we have opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles supplementary, diagonals bisect each other. Now you ask, out of these 5 qualities, which ones could we show using midpoint, slope, or distance? And if I wanted to show that opposite sides were parallel, I would use slope. If I wanted to show that opposite sides were congruent in length, I would use distance, because distance is a length concept. If I wanted to show that the diagonals bisect each other, X marks, that would have to be the midpoint going both ways. So I would find that midpoint of each diagonal. Now you only need to show one of these 3, not all 3. But you either use slope, distance, or midpoint to demonstrate first, positively, yes, that it is a parallelogram. Then you have to disprove that this is a rectangle. So you ask yourself, what are the 2 distinct qualities that make a rectangle different from a parallelogram? And of course, one of those first qualities is the fact that you have right angles in the corner. So I would say right angles, or you can say perpendicular sides, same thing. Another is the fact that this diagonal A to C is the same length as this diagonal B to D. That makes a rectangle, diagonal lengths congruent. Now ask yourself, what would it take to show you got perpendicular sides? That is a slope concept. Slope shows tilt. Diagonal lengths congruent, that of course is a length issue. That is distance. Again, you only need to show one or the other. One or the other. Show your work on the right-hand side. Check your work in class. Another coordinate proof. We have quadrilateral RSTV. And we're trying to prove that it is a kite, again, positive proof, that it is a kite, but not a rhombus. You ask yourself mathematically, what makes a kite, and what makes a rhombus a rhombus? So let's first ask ourselves, what does a kite and a rhombus have in common? What does a kite and a rhombus have in common? So I would be looking at this page if I were you, and we have here our information about a kite and a rhombus. It has 4 congruent sides. Diagonals bisect the corners. and the diagonals are perpendicular. So we ask ourselves, what do they both have in common? They both have in common perpendicular diagonals. What makes a kite geometrically? By definition, a kite has consecutive congruent sides. Consecutive congruent sides. Consecutive congruent sides. So what makes a kite distinct from a rhombus? Well, a kite has consecutive congruent sides, whereas a rhombus has 4 congruent sides. A rhombus has 4 congruent sides all around, whereas a kite has 2 pairs congruent consecutive sides. It's not congruent all the way around. So ask yourself this. If I want to prove that it's a kite by definition has 2 pairs of consecutive congruent sides. The concept of congruency is a concept of distance. Concept of congruency is the concept of distance. So if I want to show congruent sides, I would be using distance, because distance shows length. And again, how could I disprove it's a rhombus? The main difference between a rhombus and a kite, rhombus has 4 congruent sides, whereas a kite only has 2 pairs of consecutive congruent sides. Therefore, I would use distance again, because what's different is all 4 sides congruent in a rhombus. And that would be a concept of distance as well. Show your mathematics on the right and write up your explanation. For J, you should be looking at this point in your reference booklet, the summary of all the transformations. Your goal is to take these transformations and identify them for this last problem. For example, in this first one, we see that we took I, and you go from the original to I prime. Now let's ask ourselves what happened. Take a look. This coordinate right here is 1, 2. We're going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Our new coordinate right here is -3, -5. Now, if you look very carefully, we see that we went 4 to the left, and we went 7 down. That is a translation. We did a translation. And the rule was 4 to the left and 7 down. Or you can say -4 to the x-coordinate and -7 to the y-coordinate. So your goal is to go through and note whether we have a translation, a reflection, a rotation, and match it up to this page. So put this page right underneath your nose, and it's going to be one of these.